Okay. Okay. So let's first, before we start, let's summarize everything we did. So what we did here, we did actually three important laws, and these are the foundation of electrical engineering, not just circuit. Okay, and these three laws will start with Ohm's law. Ohm's law. So in Ohm's law, it says that if I have a resistance R, if I have a current I going there, then V is equal to I times R. The voltage, and we will give it this polarity, and in the coming slide, I will come to this point. So your V is equal to I times R. So this is the first important law that we need to pay attention to, which is Ohm's law. Now let's go for the second one, which is KCL, Kirchhoff current law. If I have a node, and we said a node is a point connecting two or more branches. So if I have a node, and this node has different branches, we have I1 enter, I2 leaves, I3 leaves, and I4 enters. We said that summation of I equal to 0. Or we can say current enter the nodes. So I1 plus I4 current enter the nodes equal current leaves the node, I2 plus I3. I1 enter the node, I4 enter the node, I2 and I3 are leaving the node. Or we can say that, we can assume current enter the node are positive, current leaves the node are negative. So we can say that I1 minus I2 minus I3 plus I4 equal to 0. Or I can have the convention the other way around. Current enter the nodes are negative, current leaves the node are positive. So I can say minus I1 plus I2 plus I3 minus I4 equal to 0. You can clearly see that all these will lead to the same thing. Usually we use this or this. We don't use this much, this convention, but it's up to you. But you have to be consistent. If I assume for this node current enters is positive, then current leaves, all currents leaves has to be negative, and all currents enters has to be positive. You cannot change this. Okay. Now the third law that we need to understand to solve circuit, which is the Kirchhoff voltage law. Sorry. So Kirchhoff voltage law, KVL, C, KVL. KVL says that summation of voltages around the loop, it has to be a closed loop equal to 0. So if I have something like this, I will not tell what is this now. We can talk about that later on, the polarity, I mean, how we assign the polarity, but assume we have something like this. And this is, I will call this is V1, V2, and V3. So we said that assume that you start at a certain point, you go through the whole loop, and you add the voltages with the sign of the first polarity you see. So we see here, if you're moving this way, so we said minus V2 plus V3 minus V1 equal to 0. Or you can go either clockwise or counterclockwise. So we can say here plus V1 minus V3 plus V2 equal to 0. So both of these two equations are the same. So you can go clockwise or counterclockwise. Now the question is how I specify these polarities. how I can incorporate all of these things now at once, how I can deal of integrated problem that has Ohm's law, KCL, and KVL. And let me tell you one thing here, very important, except for very, very minor cases like a circuit with one loop only, you have to use the three laws. You will not be able to solve a circuit without using Ohm's law and KCL and KVL. As I said, the only exception when you have only uh, one loop only. This is the only exception. Now, let me tell you the strategy now. How to approach a problem. How to approach a problem now. Okay. Now, let me give you some generic questions. And this is what you will have in the exam. You will have something like this. Let me give you something like this. This is a voltage. Let me call it Vs. And this is usually given its value. You will have R1 given the value. You know the value of R1, given R2 and R3. A circuit like this. And then you will be asked any question. Let's say it could be the question will be asked, what is the current in R3? Or what is the voltage around R1? Or what is the power absorbed by R3? Or any other question. You could ask you any question in the circuit. So now I didn't specify a current. I didn't specify a polarity. Nothing, just a circuit like this. Now, R1, R2, and R3 will have numbers for them. So they are giving, and Vs is given to you. That's it. Okay. So how I approach such a problem? This is the procedure. And this is very, very important. I would say this is the most important thing we will be studying this week. So the first thing now we said we will do here, number one, assign currents in every branch. So in every branch, I will assign a current. So here in this, we'll call this is as I1. Here we'll call this I2. Here we'll call this is I3. Now this is the same as this. These two, they are two branches, but they are connected in what we call in series. I will talk about this next week. But you can easily see that the current here is also I1. So all of this is the same current. Again, current is water flow. So this is like a pipe. This is like the pump. Okay, and these are the valves. Okay, so the water here is the same all over. Now, when it comes here, you see here, there are two pipes branching out from this pipe. So the current here should be different than the current there. Okay, so this is the first thing. Assign currents in every branch. Number two, assign polarity in each resistor. Now, the voltage source, you will be given the polarity. So I don't need to do anything about it. So the only thing you need to worry about is the resistance. How we will assign the polarity. This is very, very important. So if this is my resistance, and you assume the current coming this way, so this is how you assign the polarity, plus, minus. This is your V. And this V using Ohm's law is equal to I times R. But this is how you assign the polarity. So it comes here, so this becomes plus, minus, here, plus, minus, here, plus, minus. Once you assign the currents, once you assign the polarities, then you are ready now. Now you can apply KCL and KVL. Now you can apply KCL and KVL. And you will see that you have to apply both. Now, how many unknowns here we have? We have 1, 2, 3 unknowns. So I will need 3 equations to be able to solve this question. Okay? Now, let's see. Let's apply this KVL in this loop. This is the loop. Okay, this loop. So we have here this voltage plus minus is I1 R1. Remember Ohm's law. So KVL to loop number 1, which is this loop. So we will start from here. So I1 R1, and this is plus here, going here, plus I2 R2 minus Vs, I'm coming back to the same point, is equal to 0. So this is my first equation. Now I will have this equation as my another loop. Then we'll start from this point. So KVL to loop number 2. So we have I3 R3 minus I2 R2 equal to 0. Now here we have 2 equations. How many unknowns we have? Still we have 3 unknowns. So we will need 1 more equation. Now someone may say, okay, wait a second. I can get you another KVL loop if I apply KVL to the outer loop. Okay, so if I apply KVL to outer loop, which is I1 R1 plus I3 R3 minus Vs is equal to 0. So now I have 3 equations. Why you are telling us that we have to have KCL and KVL? With only KVL, I generated 3 equations. If someone can tell me why this argument is wrong, he or she will get a bonus point right now. By the way, to get the bonus point, you have to answer the questions and you have to send me your email. Last time we have 2 winners, only one sent me his ID. You have to send me an email with an ID. The values will cancel out. I don't understand your answer. No voltage supplied in loop 2. No, that's not the correct answer. Why? This is very, very important because you need to understand this before we move forward. Why we cannot rely only on KVL? I am showing you the outer loop can be created by. Okay, excellent, William. William, you get the bonus. Okay, okay, I will give it to William and Alexa, both. William and Alexa, please send me your email. I will get you the bonus. So what you notice here? If I add equation 1 and equation 2, I will get equation 3. If you add these 2 equations, you will get, because this will be cancelled, so you get equation 3. So equation 3 is not a independent equation. It depends on 1 and 2. And when you look to it here, it's basically when you have, this is loop 1 and loop 2. Loop 1 and loop 2 are separated. But loop 3, the outer one, is the summation of loop 1 and loop 2. So you are not gaining any new information. You are getting 1 equation extra. Yes, but it is just a summation of other 2 equations. So this is why you have to use KCL, and KCL here, KCL will be I1 equal to I2 plus I3. So now we have 3 equations, we have 3 unknowns, so this equation is, we call it redundant. We don't need this equation, it will not help us. Now with these 3 equations, we will be able to solve the question. Let's move on, and now let's start the real deal. So here in this question, it says find I and VCD. So here, the first thing, you have to find I1, I2, and I3. Once you know I1, I2, and I3, the currents in every branch, then you can find anything else. Power, voltage, you apply V equal to I times R. Now you know R, you know I. P is equal to I square R. You know I and you know R. So you can find anything in the question. So the first challenge here is to find the I. Yes, I1, the current enters, equal to I2 plus I3. These two currents are leaving. So a current enters is equal to the currents that they are leaving. Okay. So find I, and it will, in this question, it was given to you, and VCD. So the current is giving, so I need now first to assign the polarity. I will follow the current direction, so this becomes plus, minus, plus, minus, plus, minus. You notice here, this question is just one loop. If it is just one loop, then I don't need KCL. This is the only time you don't need KCL. You need KVL will be sufficient, and Ohm's law. So apply KVL. So we start from here, and we will go this way. So I times 10K, so this becomes 10KI. And I prefer here to keep the unit so that you know that this is 10,000. It's not just 10. Okay, 10 kilo ohm. Here I cannot use KCL because we have only one current. This is why we don't use KCL. It's the whole thing is just one current. KCL when the current branches out. One a current here, see two branches, and then you can find the currents. But here it's just one current. So 10KI plus 20, because this is the same current. The current go all the way in this loop. It's the same current all the way around. Plus 20KI plus 30KI minus 6. Come back to the same point, point A, equals 0. Summation of voltages equal to 0. So 10K, 20K, 30K. So this is equal to 60K I equal to 6. So I is equal to 6 divided by 60K. 6 over 60 is equal to 0.1. Now I'm dividing by 1,000. So this is becomes not amp, this becomes in milliamps. Sorry. Sorry, I don't know what happened. Just a second. Sorry about that. Okay, so this is 0.1 milliamps. Why milliamps? Because this is kiloamps, so this is equal to 0.1 times 10 to minus 3 amps. Remember, this is 6 divided by 60 times 1,000. So 6 over 60 is 0.1 times 10 to minus 3 amps, or 0.1 milliamps. So it's very important to note this one. Okay. Now, also says find VCD, the voltage between point C and D. So your VCD is equal to the 30 kilo ohm times the 0.1 milliamp. Now, the milli with the kilo would cancel. A kilo is 1,000. The milli is 10 to minus 3, so they will cancel. So this will cancel. Then I have 30 times 0.1, so this is equal to 3 volt. Okay, any question here, guys? You have any doubt, anything about? Let me see if you have any question here. Okay, it seems everything is clear. If it's everything is clear, so you are ready for the. Could you please the last point? Okay, VCD is the voltage between C and D. This voltage is Ohm's law between C and D. What do we have? We have only the 30 kilo ohm. Okay, so the 30 kilo ohm. This is the only thing that we have. So it is the 30 kilo ohm times the current. The current is 0.1 Ohm's law. So as I said, you need KVL and Ohm's law to solve this question. So this will give me 3 volt. Okay, hopefully now this clarifies. Now let's see your understanding. Let's do this question as a bonus. Give me Vx. So you have this circuit and we want to find Vx. The fastest one to give me the right answer will get the bonus mark. What is Vx? I will solve it, but let me see this. Those who got the idea very fast, so they deserve a bonus mark, then I will solve that. Okay, whenever I get the first answer right, I will stop. Give you more time. I know this is just a new thing for you guys. We just covered that, so I'm not expecting you to grasp it right away, but let's just have some fun. Okay, I think we have a winner. Kim, you are no, not Kim. Sorry, the first one to get it right was. Let me just check here. The first one, the fastest, always the fastest. The fastest one to get it right. I think Tia. Tia TIA, you got it right. It's 10 volt. Okay, so I think you are the first one to get it right. So please, now we have 3 winners today. Please send me your ID to get the bonus mark. So let's solve this question. So as I said, what is the first thing to do? Assign a current direction. Usually we assume the current leaves the positive terminal. So here we have 2 voltage sources. Okay, now this is a higher voltage, so we assume that the voltage current will be here, but it doesn't matter. Even if you assume the current in the other way around, you will get it right. So there's no problem. So here, this is your I. Okay, so going in this direction, usually we assume the current leaving the positive terminal. Okay, as I said, because this is higher, so we expect the current to go in this direction. Now assign the polarity. Forget about Vx now completely, as if it doesn't exist. So plus, minus, current direction, plus, minus. I'm not referring to Vx anymore, okay? Plus, minus, and that's it. So apply KVL. So we have here 2Ki plus 5Ki plus 2Ki plus 6 minus 24 equal to 0. 2 plus 5 plus 2, this is 9Ki. 6 minus 24, this is minus 18, equal to 18. So I is equal to 18 divided by 9,000 or 9K, which is equal to 2 milliamps. Now, what is Vx? Vx is 5K times 2 milliamps. The milli will cancel with the K, so this is equal to 10 volt as Tia said. Okay, now what would be the answer if the same question, everything is exactly the same? I will just do a little change here. Okay, so let me just, I think it will not erase because this is now permanent, so no problem. If the voltage was plus minus, everything the same, but Vx now plus minus, what would be the answer? What do you think, guys? 10 volt, minus 10 volt, exactly. Okay, now because the current is going in this direction, now this is against the convention we have. So plus minus 10 volt. If I reverse the polarity, then this becomes equal to minus 10. Now, these questions are good to understand the concept, but that's not the level of the exam. Let's have a question that really a level of an exam. This is a question of an exam, okay? And here it says find V0, the voltage between this point and that point. As we said, the first thing, forget about what I ask you to find. We need to assign currents, find those currents in the circuits. Once you are done, then we will see, okay, what was the question, what you are asking me for, and then we will find. So when we look to this question, I need to assign currents. So I need to know how many different currents in the circuit. So this is 24 milliamps, will go all the way until it reaches here. Then it will see 1, 2, 3 branches, different branches. Now this and this are two branches, two elements, but the current goes here is the same as the current goes there because they are in series. Okay, so this will be your I1, this will be your I2, and this will be your I3. So this is the first thing. Now I covered everything in the circuit. There is no branch, there is no element in the circuit that I did not assign a current to it. So everything has been assigned. This is number one. Number two, assign polarity as per the current direction you assigned. Okay, so this is plus, minus, plus, minus, plus, minus, plus, minus. Okay, that's it. So now how many unknowns we have? We have 3 unknowns. So how many equations I need? I will need 3 equations. Okay, so let's start with KCL. Usually we have, I mean, for something like this, it is just one KCL. You can't get more than one, this KCL. So a current enters the nodes here, 24 milliamp. This is the current that enters this node, 24 milliamps. Equal to, this current leaves the node, I1. This current leaves the node, plus I2. This current leaves the node, this is plus I3. And that's it. So this is the first equation. Equation with 3 unknowns, okay? And we need now to move on and we need to find the other equations. Now we will use the different loops, but as I said, make sure that you have independent loops. Do not use, let's say, 2 loops and then the third loop will be a combination of these other 2 loops. Every loop has to be independent from the others. Okay, so we will start with, let me just change the color so that you will see that clearly. So let me start with this loop. I will apply KVL now to this loop. So I will say apply KVL to loop. I will call this loop I1, I2 because this loop has only I1 and I2. KVL to loop I1 and I2. And we will start from this point, move in this direction clockwise. So what do we have here? Plus 6K I2 plus again 6K I2, then minus 8K I1. Okay, 6K, this is 12K I2 equal to 8K I1. Now from this, you can say that I1 equal to divide by 8, both 8K both sides, so equal to 1.5 I2. I found the relation between I1 and I2, and I will call this is my equation number 2. Now, when it comes to the math, there are different approaches. You have 3 simultaneous equations with 3 unknowns. So now it's up to you how you want to solve them. There are different ways to do that. So it's up to you how you want to approach these problems. Now let's move to the, now have 2 equations, 3 unknowns. I will need one more equation. Let me change the color and let me go here. Again, we'll start from here, go clockwise. So we'll have here KVL, 2 loop. Now which loop? Let's say I2 and I3. I2 and I3. So we'll have 8K I3 minus, now minus because when you go this way, so we're coming here, you see the first thing you see plus. Coming here, the first thing you see is the minus sign here. So it's minus 6K I2 going up minus 6K I2 equal to 0. So it's 8K I3 equal to 12K I2. And from this, you can say clearly I3 equal to 1.5 I2. This is equation number 3. So now I have equation 1, equation 2, equation 3. Let's move on. So here, let me write down the equations. Here, I1 plus I2 plus I3 equal to 24 milliamp. This is the first equation. The second equation, we said that I1 is equal to 1.5 I2. And the third equation, we said that I3 is also is equal to 1.5 I2. So one way to represent all variables in terms of one variable. So now we will go back to the first equation and substitute. So now substitute the values of I1 and I3. So we'll come and substitute here. So here I1 is equal to 1.5 I2 plus I2 plus I3, which is plus 1.5 I2 equal to 24 milliamp. So you can see here what the trick I did. I changed the first equation from an equation with 3 variables to equation with only 1 variable by using the other 2 equations to substitute for the other variables. So here 1.5, 1.5, so this is 4I2 is equal to 24 milliamps. So from this, my I2 is equal to 6 milliamps. Now, it's very important to write the units. Very important. If you said 6 and you don't continue, you will lose a mark here. So please, you have to assign all units in any question that you solve. Now, if I want to find I1, you can find If you want I3, you can find it's okay. So clearly here is I1 is equal to 1.5 times I2, which is 9 milliamps. So is I3. Okay. So now I know everything. Once I know everything, now I know everything. What does this mean? I means I know every single current in the circuit. That is my objective. Find every single current in the circuit. Now let's see, what do you want in the question? What I want is V0. What I want is V0. Can someone tell me, symbolic, what is V0? V0 is equal to what? V0 is equal to what? Symbolic, no, without, I mean, giving me the number. What will be V0? The initial voltage? I don't know what does this mean. No, what is the equation? How to find V0? Okay, excellent, excellent. 6KI2, yes. V0 is equal to, sorry guys, sometimes I ask questions for free. No bonus for those questions. Whenever I say a bonus question, then you know. Sometimes I ask for free, okay? So hopefully that's okay with you guys. You can work for free and for a bonus. So this is 6K times I2. This is your V0. Why? V0 polarity from here. This is the polarity. So we are following the convention of the current. So it's the same polarity, plus, minus, and Ohm's law. Ohm's law, the most fundamental law in electrical engineering. It's R times I. R is 6K, and I that goes here is I2. So this is equal to 6K times I2. What is I2? Is 6 milliamps. This will cancel with this, so you'll have 36 volt. Okay. So this is the solution for this question. Now with this we are done with Ohm's law, with KCL and KVL, and this question is a level of the exam question. This is what you expect to see in the exam: multiple loops, multiple branches, different currents. So usually I don't give you more than a system of 3 equations. Okay, so basically you have only 3 variables. That is the maximum. I don't give more than 3 variables. Otherwise it will be too much math, solving too many equations, too many variables. So usually my questions are including only 3 variables. If you have more than 3 variables, it means that you could have simplified this, or you did something wrong. Okay, let me now address your questions. If you have any questions now that to be addressed. Okay, what is the part that is sticking out from the second branch? Is just, yes, okay, that's a good question. What is this? Someone is bothered by this sticking out. Now, this is, you look to it as a probe. When you do the measurement, you have to have a probe. Just give me a second. I will show it to you what is it physically. Just give me a second, please. So when we do the measurement in the voltage, usually we have 2 probes. We connect 2 probes to do the measurement of the voltage. Okay, so let's say here, let's open these 2. So if I have a circuit, I want to find the voltage. So basically I have these 2 points. So I connect them. So in this circuit here, at top of the 6 kilo ohm, I have 1 probe, and this is the one sticking out. And the other one is at beneath the 6 kilo ohm. I will be recording some videos later on once we are done with this to show you that, because unfortunately we don't have labs in real time. So I will be doing some videos from time to time to explain some of the concepts. Some experiments we'll do with you, and those experiments I will record them and I will share them with you so that you have more feelings what is going on in these circuits. Let me see if there's anything else here. Okay, that's it. Okay, so I will stop here. I don't want to cover any new topic. I will leave the rest for next week. Uh, so let me stop sharing. Okay, so now what is gonna happen next week? Now we know the basics. This is the first question in the exam. Then what if the circuit is a little bit complicated? How I can simplify this circuit? Then we'll talk about that next week, how we can simplify. Is there any shortcuts? We'll talk about shortcuts as well. And next week we'll be covering two more questions at least in the midterm. And then we'll covering like three questions in the midterm about different techniques, and then we will talk about the first sensor, which is the strain gauges. This will be covered also by the end of next week. Have a nice weekend, and please, those who got the bonus marks, don't forget to send me your IDs. And the student who got the bonus mark on Tuesday, you did not. There is two students. One only sent me the email. Please don't forget to send me your email. Okay. Thank you very much. Have a lovely weekend and see you on Monday. Bye.